Good evening. My name is Hilal Prakoso. In today's video, I would like to explain to you about my final project for the Big Data System Engineering and Organization course, which is Vector Database Exploration on Mobile Phone Price Dataset. Okay, now I'll explain to you about my Python program. So, the script begins by uploading a file using google.colab.files.upload, followed by loading the dataset into a pandas data frame with pd.read._csv. And then the first 5 rows of the dataset are then displayed using dataset.hat to gain an understanding of its structure. As you can see here are the results of the dataset. And the next step is the dataset preprocessing. Firstly, uh, commas are removed from the price column, and it is converted to a number type. Subsequently, the RAM, battery, and display columns are converted to numeric types after extracting numerical values. The cameras and Android_version columns are also extracted and converted to numeric types, with empty values replaced by zeros. Similarly, the inbuilt underscore memory column is extracted and converted to numeric type, with missing values filled with zeros also. Finally, uh, missing values in numeric columns are filled with the median, while those in categorical columns are filled with the mode. The dataset is then checked for any remaining missing values. And as you guys can see here, there are no missing values left. So it's all good now. And next is embedding dataset to vector space. After filling missing values in number columns with the median and categorical columns with the mode, the dataset is processed using column transformer. Number columns are normalized using standard scalar. Uh, Category columns are encoded using one-hot encoder, and the name text column is embedded using TF-IDF vectorizer. PCA is used for visualizing the processed data, extracting its two main components, and optionally, TS and E is employed for visualizing the distribution of embedding. Okay, it is all for embedding dataset to vector space. And here are the result of the visualizing of the PCA of embedded data, and here are the visualizing of the TSNI of embedded data. Okay, the next step is data indexing with FAISS is performed as the fourth step. Firstly, the processed data is converted to a dense format suitable for this FAISS. And then an index is then initialized with the appropriate dimension and factor from the data are added to the index. The number of factor in the index is checked, and, and the sample of factor from the embedding is displayed for inspection. And here are the example of the result of the number of the index, which are this much, as you guys can see. And next step is query creation. But before we make the query, there are specific columns are converted to numeric values, and missing values are handled Numeric and text feature are defined, then combined and processed to train the nearest neighbor index. A search function, a search function is created to search um, based on the query factor with helper function to print the result. And if you want to see the details of this program, just pause the video and take a look and take a moment to see the program. And let's move on to the first query, which this query searches based on a combination of specification and price. The result is a list of devices meeting specific criteria such as price range, RAM, and battery capacity. And the search results are displays the top five rankings. As you guys can see here, here are the first rank, and and then these are the fifth rank or the last one. Okay, it's almost the same with the second query, which is it searches based on a keyword in the product name, such as Pro. The system performs the search based on this keyword and display relevant result, including product with names containing the word Pro. And also here are the first rank, and then this is the fifth rank. And then it's also the same with the third query and the other one query. And now let's move on into the optimization of the query. Okay, so I'll explain about the first query. The first query. The optimization of the first query focus on improving efficiency and relevance. This involves sorting the filter result by descending rating and selecting the highest rated data meeting the criteria. And after optimization, the execution time efficiency of the query significantly improve. As you guys can see, these are the execution time without optimization, and here the execution time after the optimization. It's also the same with the second query. It improved. Uh, the improvement were made by limiting the feature used in the search based on the keyword in the product name. Only the most relevant feature were considered, reducing the dimension of the query factor and speeding up the search. And as the result, there was a notable improvement in the execution time efficiency of the query. Let's take a look. Here are the execution time before optimizations, and here are the execution time after optimization. It's a lot more better. So it also reflected on the third query, the fourth, the fifth, sixth, and the last one is the last query. So that is all about my final project. If you want to see the full review or the full explanation, you can see from my report here, my final report here. And yeah, that is all. Thank you for your attention. Good evening.